And now, coming to you live from Huntsville Attic, it's Rockin' with Rockin Robbie. And here's your host, Rockin Robbie.
Hey everybody, welcome to Rockin' with Rockin Robbie. That is right, I am Rockin Robbie. And with me, live in Huntsville Attic, thank you for joining us. With me, I have my co-host, as usual. It's, ladies and gentlemen, Jumpin and Jivin James. Yeah.
Hello.
All right.
Everybody.
Also, Maniacal Mike. Yes,
It's crazy.
Hell yeah.
And we actually have Jumpin and Jivin James manning the audio boards tonight because we have a very special
It's
guest
very
with
odd
us.
being over here.
Tonight is a very special episode, so we have a resident science specialist with us. Everybody, please welcome to Huntsville Attic and a Smile or Else debut to the Drinkey Doc.
Yeah.
I hope you drop some knowledge today.
Very nice to be here.
Well, thank you for coming, Drinkey Doc. I hope you found Huntsville Attic all right.
That's what she said.
Well, Drinkey Doc, speaking of Drinkey, it's time for our opening shot, everybody, as is our custom here on Rockin' with Rockin Robbie. Right now, James has given us a delicious treat. James, what is it?
It's kind of like a a caramel macchiato shot, kind of.
All right,
That's nice.
caramel macchiato, motherfucker. Let's do this, everybody. Good show. Holla, holla, holla.
Hello.
That is delicious, James. Very delicious.
Thank you.
I do like that caramel vodka.
Jesus.
Well, listeners, I thank you
It
for
likes
joining
you.
us here. I applaud your dedication to our show, and I'm very pleased to announce that right now is our very first super sensational science special. Yeah!
Yes.
It's our first one, subtitled "Let's Get Physical."
Physical. I want to get physical. Physical.
That's right. It's Let's Get Physical. Tonight we will be presenting to you a brief overview in history of physics, starting from the beginning. So, we got the intro going, we got the shot in us, we got the topic. Everybody, let's explore the world of physics. First of all, what is physics? Physics is the science that studies matter and its motion through space, as well as other things like energy and forces. So, matter. The shit that is us, that makes us.
The shit.
So, everything matters. Huh?
Everything matters. Indeed, it does. Physics actually evolved directly from natural philosophy.
Natural philosophy.
Natural philosophy has its origins in the Archaic period. Thales, the philosopher, for instance, was one of the first to do this. He refused supernatural, religious and mythological and magical explanations for natural phenomena.
Wow.
So, because before that, of course, everything was about whatever your mythology or whatever you believed happened, supernatural crazy things. He was like, no, there's a natural explanation for everything that happens in nature. These are the first kind of thoughts that people had that led into physics. Aristotle wrote a book called Physics, and it attempted to analyze and define motion from a philosophical perspective. Democritus was among these guys. He was the first to come up with atoms, that in fact all matter were made out of indivisible little bits called atoms, centuries before we discovered the atom. Aristotle proposed that all of nature consisted of the four classical elements: earth, air, fire, and water.
That'd be very hard.
Then
to
they
make
lost
everything out
one
of
and
four
became
things.
a supergroup in the 70s. They're great.
Fire water.
Hey, yo.
Earth, wind, and fire. Never mind.
Fire water.
This continued until about the 18th, 19th centuries. Scientific method, Renaissance, all that stuff.
all that stuff.
All that stuff. The physics still maintains a tinge of philosophy. In fact, there's a lot of heated debate in physics today about certain theoretical things that you can't physically observe yet. Is that science or is it philosophy? Well, it's funny because physics started as philosophy and now has once again come full circle back to philosophy. So it seems. So, anybody can tell me the man who was responsible for breaking the traditional mode of natural philosophy and bringing out physics as we know it today?
Aristotle.
No, we just talked about Aristotle, Mike.
I wasn't paying attention.
Okay, that's fine.
Pluto or Galileo.
Galileo was an astronomer, not so much known for his
Go with
physics
Newton,
contributions.
maybe?
Newton, Isaac
Oh.
Newton, everybody. So
I
that
think
leads
he's
us
a
to our
sir.
first topic, classical Newtonian physics, everybody. Isaac Newton was a physicist. He was a mathematician. He was an astronomer, a philosopher, a theologian. In fact, he actually wrote more about theology and the occult than he did science and math. There's another area of his expertise that's little known. Does anybody know what I'm talking about?
Well, I'm just gonna go with the most obvious thing. I think everybody knows is he was a baker. Because I mean, those those really awesome cookies. I mean, they're cookies, but they're not. They're cake and fruit. You know.
Ah,
Is he a
Wow.
candlestick maker?
The fig Newton.
Yeah,
I
fig
guess is
Newton,
what he
cookie.
believes.
Yeah.
Yes, okay.
I thought you were doing the whole. the butcher,
Not
the
quite
baker, the
sure about
candlestick
that.
maker.
However, turning a cake into a cookie is very alchemal, if that's the correct word. Anyway, he was an alchemist.
Oh yeah,
He's
yeah.
a celebrated alchemist. Actually, at
That's
his,
what you're going.
at his death, they found traces of
Witchcraft.
mercury in his hair.
Is he a full metal alchemist?
Oh,
Only that would be way awesome.
nice plug for your show next week, Mike. Anyway, he had lectured on optics. He used a prism to separate white light into the spectrum of colors and show that you can use a refracting lens to bring them back together. He made the first refracting lens microscope. Isaac Newton was a
So
big
he made the cover to that famous album, huh?
Dark Side of the Moon. Yes, indeed, he did. Pink Floyd has a lot to owe to Isaac Newton. July 5th, 1687, he published his book, The Principia Mathematica. In these, his most accomplished laws were set. His law of universal gravitation and his 3 universal laws of motion. Maniacal Mike is our resident expert on the laws of motion. Mike, what can you tell me about Newton's 3 laws of universal motion?
First law states that if an object experiences no net force, then its velocity is constant. The object is either at rest or it moves in a straight line with a constant speed.
So basically what you're saying is an object at rest will tend to stay at rest unless it's acted upon by an outside force.
That is correct.
Indeed.
The second law is the acceleration of a body is parallel and directionally proportionate to the net force F acting on the body is in the direction of the net force and is inversely proportionate to the mass M of the body, i.e. F equals ma.
Force equals mass times acceleration.
That is true.
Basically, the heavier something is, the more force it takes to accelerate it. The third law is probably one of the most famous laws, Mike. What is that?
Yes, it is. The third law. When a first body exerts a force on a second body, the second body simultaneously exerts a force. F2 equals negative F1.
For our math experts out there.
This means that F1 and F2 are equal in magnitude and opposite in direction. In layman's terms, for every action, there is an equal and opposite reaction.
Exactly, like how we lift rockets into space.
Putting
Interesting.
people on the moon.
Indeed. Force pushes down from the rocket thrusters, pushes the rocket up. There you go. The 3 laws of motion. We are all very familiar with this. We still use these today. They're very accurate to describe objects moving through space. Universal gravitation. Of course, we can't talk about Isaac Newton without talking about Fig Newtons and the Apple Newtons. Isaac Newton and the apple. What am I talking about? Obviously,
Gravity.
gravity. That is right. The law of universal gravitation basically says every point mass in the universe attracts every other point mass with force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Jumpin and Jivin James, elaborate.
So that means that shit is pretty much attracted to each other.
Yes.
Okay.
Oh, yes, absolutely.
Okay.
So basically, Newton told us that shit moves, shit makes shit move, and that shit moves towards each other. So
So how is this different from Kepler's law of planetary motion?
Kepler's law of planetary motion. I don't know, Mike. Why don't you tell me? Newton obviously used Kepler's laws of planetary motion as well as contributions from Robert Hooke, who actually claims that Isaac Newton plagiarized him when he published the Principia.
And then he died.
So Kepler's laws of planetary motion was a long process of his life to describe why the planets were in the orbits that they were in. They did not come up with the theory of gravity or all the other stuff. Like, he used Kepler's laws, but the laws of motion as set by Isaac Newton are more of an evolution of Kepler's laws of planetary motion. If you get what I'm saying. But it didn't account for gravity. In fact, even in his law of universal gravitation, there is no reason given for why gravity attracts things. It just happens that way, apparently. To him, space and time were separate, and they were absolute. They were fixed. There was no changing. So therefore, all of his laws account for large objects moving through absolute space and absolute time. That changed later on by a very important physicist who we will get back to after our break. But before our break, it's time for the question of the day. Woo. Today's question of the day is, what to you is the most astonishing discovery of physics? We'll be right back after this. Welcome back, everybody, to Rockin' with Rockin Robbie. We are here in Huntsville Attic with Maniacal Mike.
Hello.
Jumpin and Jivin James.
What's up?
And the Drinkey Doc.
Hey.
All right. Well, once again, thank you, Drinkey Doc, for joining us. You were kind of quiet in the last segment. Not quite sure. He's here because he's our science expert, and you agreed to be our science expert. And your qualifications here are absolutely amazing. So I'm looking forward to your input on this segment, sir.
Well, I'm drinking Hennessy, so fuck.
All right. Well, that's the Drinkey Doc. So we talked about Newton, and we got to our question of the day. Once again, of course, this is our super sensational science special, part 1. Let's get physical. All right. Question of the day was that to you, what is the most astonishing discovery of physics?
Man, I got this one. It's so easy.
Oh, all right then. Maniacal Mike seems to be a volunteer. But before we get to that, it's time for our second half shot. Absolutely. This is the same shot we had last time from Jumpin and Jivin James. The Kafa Mocha Mocha Laka Camera Lockman.
Yep.
And here
It's
we go. Good
Hawaiian.
second half. Yeah, everybody. Yeah. Yowza. Question of the day. To you, the most astonishing discovery of physics. Maniacal Mike, what you got for me?
Quantum leap.
Quantum leap.
Dude,
Yes.
that was
that
like my
show
favorite back in the day.
Fucking
It was
Ziggy.
so awesome.
Yep.
I
Dude
want that
travels
little
through
calculator
time,
thing,
and
man.
Ziggy, yeah, like Drinkey Doc said.
Drinkey
Ziggy,
Doc.
shit, that thing was awesome.
Mm-hmm.
That is, especially when he went back in time, and he was the guy. Shit, I totally went blank. on
But
guy's
the
name.
one where he was the
But-
pregnant woman, or
I don't think that's the quantum
no,
leap
he was-
that you're
he was,
referring to.
Who was the guy that shot Kennedy?
Me. That wasn't me.
Oswald?
Oswald.
oh,
Yeah,
yes.
yeah, he was Oswald,
Yeah.
and he was in the tower, and he's like, "I can't do it. I can't do it."
Wait, Scott Bakula, was that the first episode?
No, that was one of the ones toward the end.
Did he go into? Who did he go to in the pilot episode? The first one. Does anybody know? Anybody
I
remember?
don't remember. That's just-
Well, absolutely.
that's like
been a
physics to
while.
me.
Well,
It's-
quantum leap absolutely is mysterious and strange, and we will get to it in our next segment. But anyway. Moving on. Jumpin and Jivin James. What to you is the most amazing discovery of physics?
I'm like gonna go with the quantum entanglement.
Ooh, quantum entanglement. So far, a pair of quantums.
Oh yeah.
Quantum entanglement. Another thing we'll be getting to our next segment, and obviously we must be talking about some quantum stuff. Spoiler alert: Drinkey Doc.
Yes.
Most astonishing scientific physics discovery to you. What would it be, sir?
I have observed this many times. The law of falling body.
The law of falling bodies.
Yes.
All
yes,
right.
yes.
What would that be, sir?
Well, evidently, that guy overturns nearly 2,000 years of I can't spell, but belief that heavier bodies fall faster than lighter ones. Trust me, fat bitches fall faster.
All right.
Very true.
Actually,
that
that
would
was
be Galileo Galilei.
Whatever.
yeah, that is Galileo Galilei
Whatever.
of the
And,
15th century. I believe.
I think it's 2,000
17th
years of
century.
Aristotle.
Oh, you're a smart one, aren't you?
Belief. I think that's the
Why
term.
don't you fuck off?
The most astonishing physics discovery to me is Einstein's general relativity. It's so counterintuitive. He made logic override reason, and really, it's astonishing to me that his theory of space and time are actually linked and that they are relative.
Is that equals MC squared?
Equals MC squared is a side effect of special relativity.
Oh, okay.
In fact, let's go ahead and get into this then. Albert Einstein was German. He was a clerk in the patent office. So even though he came from humble beginnings, he had a brilliant mind. He felt that Newton's mechanics, the classical mechanics we had just discussed, they no longer were enough to reconcile with the laws of the electromagnetic field, which was, of course, discovered by Maxwell. And
Whoa.
what?
Maxwell discovered that? You talking like R&B jazz sensation?
Absolutely.
Maxwell?
Doesn't that blow your mind, Maniacal Mike?
Holy shit.
So this
Drinkey
led
Doc shit. I know that's what he uses
to
get
his
down.
theory of special relativity. He then thought relativity could be used in relation to gravitational fields. This led to general relativity. We'll get to all this real quick. Special relativity. Jumpin and Jivin James, what can you let me know about a little bit about special relativity? Sir?
Well, one of the main reasons they had you try to figure out something different with the physics they were working with is because in 1887, Michelson and Morley did an experiment trying to prove the fact that the speed of light did change, and they could not. So they had to come up with an answer for that. And then in 1905, that's when they released On the Electrodynamics of Moving Bodies, which
Absolutely.
then explained that the speed of light was constant.
Indeed, Einstein was the main proponent that the speed of light was always constant to any observer, no matter what they were moving in relation to each other.
I hate to interrupt, but there's one thing I got to say that I always loved about Einstein. Is he had a hot niece.
You're talking about that movie with Walter Matthau as
What
Einstein,
was the,
IQ,
last time you said.
with Tim Robbins.
Ooh.
That's a good movie. Anyway, he was a big proponent of the fact that the speed of light was constant to all observers, and that it was the speed limit of the universe. Nothing could move faster than the speed of light. Basically, special relativity states that the laws of physics are the same for all observers in uniform motion relative to one another, and that the speed of light in a vacuum is the same for all observers regardless of relative motion or the source of the light itself. Motion slows time. That's a part of this law.
The time dilation.
Time dilation. Absolutely. E equals mc squared. The world's most famous equation comes from this. Basically, that energy and mass are equal and transmutable. Also, the fact, like I just said, nothing moves faster than the speed of light, which is 671 million miles per hour. That is very fast. Very, very fast. He eventually realized, of course, this could go along with gravitational fields and form general relativity. Basically, that space-time, that's right, space-time. Space and time are not separate, and they are not absolute. They are, in fact, linked together like a fabric, and they have a curvature. Space itself has a curvature. Drinkey Doc is our relative general expert. Drinkey Doc, what can you tell me about Einstein's general relativity?
Well, not much there, Robbie.
Really? Okay.
Yeah.
Well, of course, you know that, for instance, clocks run slowly, more slowly in a gravity well.
I can tell you that I haven't done much research, and that this bottle of Hennessy is, I don't know.
Also, that rotating masses twist and drag space-time.
Heavier objects seem to fall faster.
No. Light bends in a gravitational field.
It's
Light
all about.
rays will bend.
It's like a woman. It's all about curvature.
Yeah, yes, absolutely. Actually,
okay,
it is all.
right.
We could do that. Light bends. Is that a bend for All About the Benjamins for the next one?
No.
I don't know. That's stretching a little bit. But basically, yes. Space is like a fabric.
Kind of like what you're doing right now. Right?
In general relativity is inexplicable. So yeah.
Oh, I mean, not quite. It's very explicable.
No, it's not.
Generally speaking, yes, it's relatively.
It's not very relative.
No. It's a fabric. Space is a fabric. It can move.
Right.
It can bend. In fact, gravity works. Einstein he wasn't satisfied with Newton's law of gravity because it never explained why gravity has a force. And it also said that if Einstein's laws were right, if Newton's laws were right, gravity could actually move faster than the speed of light. He knew that wasn't true. So therefore, space as a fabric, imagine it like holding out a blanket and putting a bowling ball in the middle, and you got a bunch of little like ping pong balls and fucking pool table balls around, and they'll be drawn to it.
Or like a hooker
Masses
in a
in
waterbed.
space are drawn to each other because they create curves in space-time itself.
What?
And the planets and stars and galaxies move along these curves in the fabric of space-time itself, and that's how gravity actually
And what
works.
about Neptune and Uranus? They all switch and shit.
No, they don't. They actually, I don't.
Yeah,
What,
when they
what?
go to the orbit, it does this.
I think you're
Yeah.
talking about Pluto and Neptune.
No.
And
This
that's
has
because
nothing to do with my anus, Mike.
Pluto is actually a stray object
No.
from the Kuiper Belt.
It's.
But once again, you're veering into astronomy
It's
territory, and
Uranus.
this is a physics
But
episode.
I'm telling you though, it's Uranus and Neptune.
All right.
Well, if you're doing physics, and where Schrodinger's cat come into play? They talk about it all the time on Big Bang Theory.
Is that where you get all your physics research, Maniacal Mike? Is from
Yes.
the Big Bang Theory?
Yes.
Wow. Okay. Well, that's obviously evident tonight. Luckily, we have our expert, Drinkey Doc here.
Drinkey Doc.
I don't know what we do without him.
Drinky Doc, you telling me that Sheldon's
Drinkey
wrong?
Doc.
I don't know who the fuck that is.
You guys understand the implication of space and time being connected and changing, right? Like that space and time will change and bend because of your motion. It will bend and change specifically so that the speed of light stays the same. Why does the universe work that way? Isn't that crazy to you?
I saw a documentary where a ship was built, and they went through a black hole, and it went from one place to the other.
You know, black holes are created because of general relativity. It warps space-time so much that it drags down into almost nothing,
In the
like
first
almost maybe a
version,
rip. What?
The documentary that I saw from the 70s, black holes were the gateway to hell.
Are you sure this was a documentary, not a science fiction film that you were watching?
I don't know. I was young.
All right.
Anything that's on TV is true, right?
But
I've
so
been through
space-time changing, that's absolutely astonishing, is it not, Drinkey Doc?
I've actually been through a black hole.
What was that like then?
I don't remember. It involved Gentleman Jack.
I got a question for the Drinkey Doc and for Robbie. Didn't Einstein split the beer atom?
The beer
what?
atom?
Yeah, the beer atom.
I'm lost.
I'm lost too. What's the beer atom?
Special guest to explain the beer atom.
All right, ladies and gentlemen, we have here making his Rockin' with Rockin Robbie debut, Smile or Else debut, in fact. It is, ladies and gentlemen, may I present to you our dear friend, Delightful Dave.
Hello, ladies and gentlemen. You not aware of the documentary Young Einstein?
Oh, yes.
documentary?
He invented the guitar as well, right?
Yes.
Okay,
And
okay,
he
yes.
found a way to put bubbles in beer, which before beer had no bubbles. He split the beer atom, giving beer the bubbles.
Ah, dude.
He also had the hots for Mary Curie, I think, in there.
He also discovered, that space and time are connected, and that they bend and twist to keep the speed of light relative, right? I mean, like to keep
but
it
he
constant.
also played a rocking guitar, dude.
Are you?
Come on, baby. Let's do the twist.
Well, he also had crazy hair. Let's just talk about Einstein's hair then.
No,
Right?
he really had
Dude, I
an
can
awesome
so do that
stash.
right now. I mean, look at that. It's like
Mike, you have Einstein hair all the
I
time.
know.
Anybody have any other thoughts they wanted to share on general relativity?
No, because I've got 7.5 pages for Newton's laws of motion,
Yes,
and
Mike.
I only went through like a paragraph.
Well, why did you have 7.5 pages for 5 minutes? I told you it was going to be 5 minutes. What?
I thought we were gonna go into it a little deep like into like Drinkey Doc deep.
Wow, that's getting annoying. Well, Einstein ended his life trying to unify
He ended his life?
general relativity.
I thought he died in his sleep.
He didn't.
According to IQ, he died in his sleep.
He didn't.
He faked a
No,
heart
he
attack,
didn't
but
die.
then died in his
I didn't
sleep.
mean he ended his life like he ended his life. Einstein died trying to unify quantum mechanics with the laws of general relativity, which we will find out do not mesh very well together in our next segment. That leads us to our next break. Thank you, everybody. That was a very
Kinda like vinegar and honey.
yeah, that was a very inspirational conversation about general relativity and special relativity, and time travel, for instance. Is explained. Isn't
All I
that
know
crazy?
is that if we got to watch the documentary that Doc Brown did if we're going to discuss time.
All I
travel.
know is Ron Popeil invented time travel. Yeah.
And that you got a slingshot. If you're in a spaceship, you can slingshot yourself around the sun to go back in time to save.
Anybody
worlds.
that knows anything about quantum mechanics knows that it's all about probabilities, and Einstein could not accept the probability, the probabilistic nature of reality. He, in fact, said God does not roll dice, to which another scientific revolutionary, Niels Bohr, said, stop telling God what to do. That leads us to our thought for the day
Heisenberg.
at the next break. Heisenberg will be mentioned. Today's thought of the day comes from, of course, Isaac Newton. My bad. Today's thought for the day comes from Albert Einstein. Science is a wonderful thing if one does not have to earn one's living at it. You're listening to Rockin' with Rockin' Robbie, Super Sensational Science Special number 1. Let's get physical. We'll be right back.
Another good intention falls through the cracks, and I was trying so hard just to another snack. You know I meant well, but somehow it went right. The fault's on our own, but I continue to try. Get on the road to hell. It's paved with good intentions, and my intentions are always good. stretch myself too thin, and something doesn't get done. It never left my side. Now it's gone and nothing's right. How can I change this? Make it more than just goodwill. You know the road to hell is paved with good intentions, and my intentions are always good. Always good. Always need to find a way to make this right, a way to turn this around. I can't keep going on like this. Need to fix it somehow. Maybe with a bit of luck, I can find a way, and I can make this more than good intentions gone astray. You know the road to hell is paved with good intentions, and my intentions are always good. You know the road to hell. You know the road to hell. You know the road to hell. And my intentions are always good.
That was very interesting.
Welcome back to Rockin' with Rockin Robbie here on Smile or Else. That's
shit, I
right,
got a head
soeproductions.com. Be sure to check out our website and Facebook every week, every day. If you can, we update every week, every Monday, a new show. This is our super sensational science special, part 1.
I thought it was spectacular.
It's sensational. Let's get physical. With me tonight, of course, is always Jumpin and Jivin James. Maniacal Mike.
Yes.
Special guest, the Drinkey Doc.
Where the fuck am I?
And popped out of nowhere, Delightful Dave.
I'm
It's just
here.
a pleasure to be around.
Always a pleasure.
He is
always.
so happy. So happy.
Well, we discussed classical Newtonian physics. We discussed Einstein's theory of relativity. That leads us to the age of quantum. Quantum mechanics is the theory of physics that describes matter at the atomic and subatomic levels. That's right. We have found that at that level, the subatomic level, we have found that the laws of general relativity don't work. The laws of the big do not correspond with the laws of the small. The laws of the small being quantum mechanics. Does anybody know anything about quantum mechanics? You want to, it's crazy, is it not?
Well,
Maniacal Mike?
I don't want to blow your mind, but
Hold on a second, real quick. I forgot, as always, in the third act, it's time to do our third act shot, everybody. Once again, the caramel laca mocha whatever that James has prepared.
it's
Even
Hawaiian.
It's a
Even though I
quantum
don't-
mechanics, everybody.
Even though I don't have one, in some other dimension I do.
That is right, Drinkey Doc.
The Drinkey
Quantum mechanics was pioneered by a bunch of scientists, some very famous ones, Niels Bohr, Heisenberg, Schrodinger, some names that we are all familiar with.
And
One
a
of the
cat.
what?
Right.
Who?
And a cat.
And a cat.
And Adam West, of course. I mean,
of-
Herbert.
Of course.
Sorry.
Niels Bohr was discovered that, in fact, energy is quantized. That's where the term quantum comes from. Energy is quantized. That came from the discovery of, as Mike so eloquently said last segment, the quantum leap. Jumpin and Jivin James, I notice here on your file, says you are a resident quantum leap expert. What can you tell me?
I know more about that show than he does.
Yeah, I guess there was a mistake on the reading on that.
Oh,
I'm just a big Scott Bakula fan.
Man, when he
I should have
made
realized
his
that
TV return to
because
Chuck,
you like Enterprise.
Dude, that was awesome.
Hey, it's been a long road getting from that.
I mean, I don't know. He might be worse than Janeway to me, as a captain, as a
Yep,
Star
but-
Trek captain. What do you think, Delightful Dave?
Cisco was the worst in my opinion.
First of all, he was
Cisco's
a
my
commander,
favorite.
but he's my favorite.
I don't know. I pretty much got to go with Picard on everything.
But what do you think about Bakula versus Janeway?
Bakula versus
Archer
Janeway?
versus Janeway, I guess you would say.
Yeah.
Well, when you say Archer, are you talking about like the FX TV show Archer? Because that dude can blow anybody out the
No,
water.
we're talking about Cap. You know what? Never mind.
I was never a fan of Janeway, really. I think Chakotay,
Well, she made tough
I think
decisions.
Chakotay would have been a better captain.
He actually would have been.
But how many times did they break the Prime Directive in that show?
Well, damn, dude, you're lost. You're like fucking light years away. You're like, what, 70 something light years away? Were they? Or
Yeah,
is
it's
that-
called,
so-
but it's called a Prime Directive for some
So
reason.
you're saying
man.
that the island was really in space?
no.
you
What
can't, you can't. I'm saying you can't break the Prime Directive and leave like some
There- oh,
fucked up
that's it right
breadcrumb all the way back to Earth. You know.
well, that is what
If
happened.
you go to a black hole, definitely would be through hell.
Basically,
Victoria's on
energy
an
is
island.
quantized, which is a very odd statement. They found that when they heated gases in a tube and looked at the light that they emit through a prism, unlike the smear of the rainbow that you would normally see, in fact, they were very distinct lines. Not a smear, very distinct lines. They didn't understand that.
Huh.
Why? Bohr was the one that theorized that it was because electrons have fixed orbits. They orbit the nucleus of the atom, much like a planet orbits the sun, but they are only allowed to have fixed orbits and certain minimum amounts of energy.
Hey, Robbie,
Yes, Drinky
do
Doc.
you know why Niels is so
Damn,
boring?
Where does that come? Why was he boring?
He was such a bore.
I'm glad I'm the only one that found that funny.
So electrons are in fixed orbits around a nucleus of an atom, and when they are excited or de-excited or unexcited or
Aroused?
anyway, agitated or de-agitated.
I think you're agitated.
Anyway, heated up or cooled down, the electrons will. You guys got me all fucked up. The electrons will leap to another orbit, and therefore, like in a downward leap, they will put out energy in the form of photon light, and they only do it at very distinct wavelengths of light because of the quantum leap. Basically, they move from orbit to orbit without going the space between.
Does that make neon lights work?
I'm not sure. And so
What about a neon Bible?
it was very crazy because it would be like, what if Uranus all of a sudden changed orbits with fucking Venus all of a sudden without moving the space between? It's very unreal. It's counterintuitive. It's crazy to me. Isn't that crazy to you guys, the quantum leap? But that's actually what the quantum leap is. I mean, it's very interesting. But basically, it told us that electrons. It told us that electrons follow a different set of rules than the planets and the stars and the galaxies and us. How could that be when we're all part of the same reality? Then came the double slit experiment.
That's my type of experiment.
Indeed. Do you know anything about the double slit experiment, Drinky Doc?
Well, you have to have a lot of stamina.
That's right, because you take particles like an electron or a photon, and they would throw them at a board with two slits.
Oh, it's like throwing a hot dog down a hallway, except you got two.
Two hallways.
Yeah.
You throw, okay. So you throw hot dogs towards two hallways, and you put a detector screen at the end of the hallways.
Right.
And you expect, if you throw a multitude of hot dogs,
right.
that some will go through each of the hallways,
I would expect that's a good pornography film.
and some will hit the wall and not hit the detector screen. So you would
Right.
see a pattern of two hallways on the end of the hallways, right?
Indeed.
A hot dog splatter, I guess. Sure.
Yeah,
And
what?
however, they found that they got an interference pattern, like a wave. So
Like
therefore,
a gravity wave?
what? Yeah, like a wave, like an ocean wave, a gravity wave, any kind of wave, like a wave. Therefore,
like a gravity
light
wave.
is both a particle and a wave, which
Gravity
is very.
wave is a little bit different, but we'll get to that later.
I'm sure we will, and but it was odd, and And basically, this tells us also that like this is true with all matter. You guys really got anyway. Particles and waves, and basically that it's all about the probability that we can never accurately determine. You know,
In fluid dynamics, gravity waves or waves generated in a fluid medium or at the interface between two media, which restoring force is gravity or buoyancy.
a long story short, particles don't exist in any specific place until we observe them. It is the act of observation which makes something where it is. That's where Schrodinger's cat comes from. Like, for instance, the moon technically is in all probabilities, all quantum probabilities, until we actually observe it. And then all the averages come together, and it is what it is.
So you're saying that the moon is not out there? I just believe that it's out there until I actually look at
No,
it?
it's out there because of observation. Particles are in a state of quantum probability until they are observed.
But if I haven't seen the moon tonight at all, does that mean the moon is not out there?
Well, other people probably see the moon right now.
Yeah, but then they have to call me and tell me, hey, Mike, there's the moon. The moon's outside. And I'm like, okay, cool.
Well, yeah, I guess so. I mean,
have you seen the moon tonight?
no, I haven't. Not
Okay,
tonight.
then, so obviously then we haven't seen the moon, so how do we know the moon's out there?
Well, it's like the cat in the box. How do we know if it's alive or dead? In fact, it exists in both states until you open and observe and find out.
Everything dies, so I guess it's going to be dead.
And the wave function collapses, right, guys? The wave function collapses into one reality.
I think that's correct.
I
Yes.
don't know, man.
But if you roll a dice,
I'm pretty
you-
sure you'd hear a cat in a box, man. It wouldn't be happy.
On Cat in the Box, the same
Well,
thing.
I mean, it's a
we
soundproof
can-
I mean, you don't
box.
have to.
It's a
You don't
soundproof
have to
box.
see it to know it's there. That thing will be fucking growling.
Well, it's a
Come on.
soundproof box, though.
Okay,
So,
I can
mean,
make
it's just
a-
A soundproof box.
it's just a thought
A
experiment.
cat wouldn't
I mean,
even be able to breathe in the soundproof box.
I have got...
Was he trying to kill the cat? What kind of sadistic motherfucker was this?
All I know is that I can
He was a
make
great man of science.
I can make a soundproof box, and we can put creamsicle in it and see what happens. If he's just... If we can
he didn't
hear him-
actually do this. I mean, he didn't actually do this with the cat. He was
Then
just
how
wait,
is it
wait,
done?
wait,
How
how
do
do
you
you
call
call
Then
it
why
an
are you calling it an
experiment?
experiment if you didn't do it?
It's a thought experiment.
does
it's a thought
Creamsicle
exercise.
does Creamsicle breathe sound?
Well,
Yes.
Okay.
Obviously the uncertainty principle is the next topic. Fuck it all. Basically, it just says that you can't measure both the speed and the position of a particle. If you know where the particle is, you don't know how fast it's moving. If you know how the velocity of a particle, you don't know where it is. Right? Anybody, you guys?
I'll agree with you
Wow.
on this one.
The uncertainty, Heisenberg.
Yes.
That's the uncertainty
All I
principle.
know is, but the only thing I don't know about Heisenberg, other than that, is he makes some hella crystal meth.
Interesting. All right.
Motherfucker, I ain't never seen Breaking Bad.
Quantum entanglement
To our audience,
is another
Oh,
crazy
yeah,
thing about
yeah.
quantum mechanics.
It's an awesome thing.
James mentioned quantum entanglement. He loved it. Anybody know anything about quantum entanglement?
Yes.
I don't know.
Oh yeah, what's that, Drinkey Doc?
Drinkey Doc. Forgot.
Oh, delightful Dave, you had something to say.
I just don't recall him ever talking about it in the Bible, and I kind of doubt anything that's really not in that good book.
Spoken
Oh.
like a fuck.
That's a very valid.
like a true Southerner.
Well,
Jumpin and Jivin James, quantum entanglement.
well, quantum entanglement theorizes that, and knows that if you have particles somehow can be entangled.
That's right. I believe if they are close and they can share their properties.
Yes, but then those two things can somehow be moved apart from each other, and they will still have effect on each other.
Absolutely, it's absolutely astonishing.
I totally get it. It's like Kevin Bacon.
How so?
He's entangled with every motherfucker.
Is it kind of like?
I guess so.
Is it kind of like a rat king?
A rat king?
Yeah. Like when it's a bunch of rats are all together and their tails get tangled up, and they can't separate out, and there's just one big
No,
one
no,
gets wrapped.
for instance, like two electrons, if they're close together, their properties can become shared. They'll become linked,
Yes.
and no matter how much space you put between them, for instance, like electrons, one of the properties of electrons is spin. It's either counterclockwise or clockwise. They can become entangled in such a way that if you observed a particle on Earth that is moving counterclockwise, then that guarantees that the particle on the moon that you're not seeing is the other way. So basically, if this was red on Earth, that guarantees it's blue on the moon. And if you go to the moon and you look at it and it's red, then it's blue on the Earth. That means that the observation of one particle in one point of space affects another particle in another point of space, completely not connected by anything other than spooky action, because the information goes faster than the speed of light.
Yes. So, this little theory and thing here makes teleportation possible.
It absolutely does. In
Then
the
how
very
come
far,
we don't have teleportation?
because there are
'Cause it's very
billions
hard
of
to do.
particles. There are more particles in your body than there are stars in the observable universe. So until we have the technology where we can accurately scan and reconstitute that information quickly and efficiently, it's
yeah,
still
but
going.
is it really teleportation? Because is that you on the other side of it?
Basically, it's a
That's
copy.
the-
It's more of a
that's
copy.
kind of the
Because
problem.
the
with it.
original you gets destroyed in true teleportation.
It does. Yes, they take they record the quantum state of each particle of your body and compare it to that, because he's a mutant.
He
ability.
bamps.
He
It's a little
bamps
bit
through
different.
another
Yeah.
dimension, I believe,
Okay.
if I remember correctly, and and so they compare your data with the particles in another chamber, which are entangled with particles in wherever you want to go, and then comparing the data, they reconstitute you out of those other particles, and of course your body would get destroyed in the process, but a whole new you down to the T, because every quantum state of every particle in your body would be reconstituted perfectly. Supposedly it would be you, a brand new you.
Well,
But what if people started changing things?
Well,
I think they could. What if you could? Like, if
But
you
what
could
if- but-
change what?
but you know, in
the
another
butt?
documentary that I saw in the 90s, they talked about how they were making duplicates of an individual,
Mm-hmm.
but the individual, the original was still alive, but they
I don't think this is related
They
to
tried-
quantum entanglement.
but
Hey,
they
Mike.
tried to clone.
Hey,
It's
I saw
cloning.
that. I saw that movie,
But it
and
was-
that was not a documentary. That was called Multiplicity.
Yeah, but I mean, a copy of a copy was
With
you know,
Michael
the copy of the
Keaton?
copy. Yeah, the copy of the copy. Was
That's
imperfect.
that's not a doc. Yeah, Drinkey Doc is actually. Oh my God! Why does that keep? What? That has nothing to do with quantum. We're talking about particles transferring information
But the whole
through
teleportation
spooky
being,
action.
being you said a copy, and that just reminded me of a copy. Of
But
a
yeah, but
copy
the-
was bad. Because remember the fourth one, hey Steve, I like pizza. That was the copy of the copy.
This segment brought
so
to you by
the copy of the
Kinko's.
copy,
I don't.
would that slowly
I
start
haven't
to break
seen
down?
multiplicity. Do you like multiplicity that much?
I got to study up on my physics.
Well,
when
I
can.
think the key thing here is that it's an
wouldn't it be
exact
cool-
copy.
Wouldn't it be cool if teleportation just started off as you being copied somewhere else to carry on your task while you stay where you are? It's a direct copy that has all the information that you were going to give, the task that you were going to accomplish.
So like you could send it to work
and
or
that way
something.
you don't have to worry about being like dying, because that's what being destroyed is, man. That brings up the whole concept of the soul.
So you can make like daily backups of yourself.
That is true.
You just have multiple yous running around the galaxy accomplishing the tasks that need to be done and sent
And if
back.
you could get, and if you
And
were
then
to
beyond that point, you can just go on to live separate lives.
but if your copy got close to you, could you absorb it in?
And absorb all their knowledge and become twice as powerful.
Yeah.
I think
Dude, I
that's.
think we should
you
totally
guys
do
are-
this.
I
That'd
think
be
you guys are
awesome.
talking about multiple man now from X Factor. We're talking about particles becoming entangled, and thus the observation of particles are
Oh.
wherever they are. They're in a probability wave, and then when you
So how
observe
many
them, it picks
particles
what.
are in this?
A lot. Like for instance, if you took every particle in the Empire State Building, right?
Yeah.
And took away all the empty space in those particles and put it down to whatever, it would be in the size of a grain of rice, but still have the same weight.
And
That
that's the
crazy?
Empire State Building.
Yes.
Dude,
That's
that'd be the
heavy.
best model
Adam's got
ever.
space for days. But yes, basically,
Would be the best what?
the quantum
Marble.
world's very fuzzy. Things aren't always, they don't always be in the same place. You know, they go from here to there. It's all about probability. It's not
So they're temperamental,
set.
huh?
Yeah, and you can't unify it. General relativity and quantum mechanics don't go together right now, and that's the biggest mystery in physics, and that is leading to a bold future with such theories as quantum gravity and string
Holy
theory.
shit! I fucking got it.
Well, what's
Women are dark matter.
But even dark matter matters. Well, with that, I thank you. This has been a very delightful and very. This has been a show. Thank you for joining us here on Smile or Else. This is Rockin Robbie, of course. I want to thank my guests once again, Maniacal Mike. Thank you.
I so pissed him off.
Jumpin and Jivin James. Thank you.
No prob.
Drinkey Doc. Oh my God! Would you stop? Delightful Dave. Thank you, guys. Everybody. You can't hear that? Are you... Anyway. Oh, my God.
Drinkey Doc.
The Drinkey Doc.
This is Rockin' with Rockin' Robbie. This has been our super sensational science special.
Drinkey
Number
Doc.
one.
The
Let's
Drinkey
drink
Doc.
physical. Oh, my God. It won't stop.
Drinkey
Next week,
Doc.
Smiler Show. Mike, favorite animes, right?
Yeah. Special guest, trivia, and the meat.
Ah,
Top 5 favorite.
awesome. Looking forward to it. Anime, that's right. In 2 weeks, Rockin' with Rockin' Robbie. It is, that's right. It's the most wonderful time of the year. That's right, everybody.
It's your birthday?
I hope you're in this holiday spirit because it's our extremely extraordinary Xmas extravaganza. So, speaking for everybody here in Huntsville Attic on Smiler Else, thank you for joining us. Join us next week for Smiler Else. Join us 2 weeks for Rockin' Robbie. Check the website all the time and our Facebooks.
Yeah.
I'm Rockin' Robbie. Thanks for rocking with us.